Yes, good afternoon all. I'm Swastika. I'm going to explain an ensemble method in a machine. We know that currently in current era, machine learning is a booming topic, hype created topic. In a machine learning, we are having a different technique for different applications. Among those different techniques, I'm going to choose one technique for different applications. That is, I'm going to explain about an ensemble method in a machine learning. Today's topic, I'm going to cover what is an ensemble method in the machine learning and why do we need ensemble technique and types of ensemble method. Okay, before getting into the topic, if I take a general definition for ensemble, in a normal definition or a normal term for a ensemble method, in a normal English, if I take, it's a group of element or a group of items. What we are going to group together, that is called as an ensemble. Okay, example, group of students or a group of faculties or a group of ministers or a group of dancers. Like that, what we are going to group together, that is called as, that items, it is called as an ensemble. If you compare that with the real-time example, here we have considered one real-time example. I have taken an internet course. Here, how to pass a bill in a parliament using ensemble method, how it works, and how if I take in individual method, how it works. If we compare that one in a real life, we'll come to know what exactly ensemble method is. Suppose a bill, what we are going to take, that passed in the parliament and a meeting held for the same group of ministers. Okay, if president, individual president or a prime ministers, if they are taking individually decisions themselves, okay, that is not a good idea. It is like a dictatorships. Okay, in out of these results, what we are going to get, that is not a favor for a public. So this analogy, how it will be helpful for a public. This analogy can be referred as single model like a decision tree. Take it. So what it will do, it will perform less better than that ensemble method. If you take a decision tree regression, ensemble method, what happens, that same meeting, it will be held between the different ministers, like minister 1, minister 2, minister 3, minister 4. Let's say 4 of them. Each will be having different opinions with their pros and cons. So finally, what we are going to do, based on their opinions, we are going to choose among them one majority of voting we are going to consider, we are going to take it. So what we are going to take exactly majority of one voting based opinion, that is called as a ensemble method. That is called as a ensemble method. Here also, minister 1, pros and cons, he will say yes, bill should be passed. Second person, what he will do, based on his pros and cons, he will say it is not useful. You may get challenges in the future. Like that, he will say. He will give the contradictory statements. Then third one, he will say that you can pass a bill. The fourth person also, he will say that you can pass the bill. So if you take all this aggregation or a voting method, pass bill, right? This voting aggregate, we'll call it as a pass bill. Pass bill is result. So we'll get the better results among those. So this is called as an ensemble method. Okay, this is called as an ensemble method. Now, what is ensemble method in a machine learning? We will see. In machine learning also, it is one technique. What it will do, it will use the different model or else same model for different output. Okay, or else weak learners model, what it will do, it will derive an output, or else it will provide some predictions. That prediction ensemble method. Okay, how that ensemble can build? It is a built based on a combination of different models, like example naive based, decision tree, SVM, random forest, regressions, whatever you can take, all those things combined a model that is called as an ensemble method. Here, one example we have taken. Random forest is one example for ensemble. What it will do, it is using a multiple decision tree and it is creating a predictions that is called as a ensemble. But here we are using a same method for a different output. Okay, that is a random forest. How before getting into that, I have given here weak learner term, right? Have given here weak learner term. So in ensemble method, if you are considering, we are having two type of a classifiers. One is weak classifier and a strong classifier. Strong together in figure only we can make it strong together and a weak individual. Weak individual in the sense what happens? It is like individual opinion. I have given different analogy, right? That is for ensemble method. Likewise, it will work. If I take individual opinion, will not get the better performance compared to ensemble method. Okay. If you take a stronger together, all the opinions, if it is combined and if you are taking, we are going to get a strong results. So in ensemble method, what I have taken a two classifiers, right? Weak classifier and a strong classifier. Weak classifier, what happens? It is a binary classification. What it will do? It will perform slightly better than random guessing. It will slightly, it will perform, but it will give, it will not give better performance than ensemble, but it will give good performance compared to random guessing. If I take a strong classifications, what happens? This model, it will work on binary classification. Okay, binary classifications here it will perform arbitrary performance. So it will what it will do? It will perform much better than random guessing. Whatever random guessing is there, it will perform much better than that. If you take a weak learner, okay, easy to prepare. That whatever the data set or else whatever the trained data set is there, it is easy to prepare, but not desirable due to low skills. Some low skills it will be there. That's why it is not a desirable. If you take a strong learner, hard to prepare, but we are going to get a desired output because of high skills. Okay, that's why we are going to use this ensemble method. Already I have given, right, ensemble method. How exactly works? The training data model 1 we are going to pass, training data model 2, model 3, like that we are having a different models. Different models it will give the different predictions. All these predictions we are going to take and we are going to generalize it. That predictions will, this combinedly will call it as a ensemble method. Okay, if we are building highly accurate predictions, okay, that is a tough task. Okay, that is a difficult task. What are the challenges we are going to face during a prediction errors? Okay, that is broken into three parts. One is bias, variance, and a noise. Bias means we are going to get average of distance between predictions and a target. Variance means variability in the predictions. Noise means it's a part of target value which the model is not able to predict and explain. Okay, as we know that it is impossible to reduce the noise because it is irreducible error. We shift our focus on reducing a bias and variance. Okay, so ensemble method, what it will do? It will bring the technique to reduce this bias and variance. Okay, bias and variance model by using a multiple model, by using a multiple model together, whatever we have ensemble, and in order to achieve better predict performance instead of single model predictions. Okay, that is how your ensemble technique it will use. Why do we need ensemble technique? Okay, first one, the errors and predictions in the machine learning models are adversely influenced by bias and a variance noise, right? Already I said if we want to reduce variance and bias, we are going to use an ensemble technique. In order to combat this disadvantage, we are going to use this ensemble method. Okay. Here, what are the different types of ensemble methods are there? Here mainly means we are having different methods, but among those we have chosen bagging and boosting and stacking. This is a main method, and random forest is optional one. Okay, what is bagging? Bagging is also known as a bootstrapping aggregating. Here what happens, we are having a multiple versions of a predicted models, it will be there. Example, here only we have taken, right? Data training, it will be there. And B1, B2, B3, that is a bootstrap samples, that is a data. And that we have sent it to the model. So M1, M2, M3, that is a model. We are going to get an aggregation or also voting of out of these predictions that we are going to get as an outcome, that is called as a bagging method ensemble. Each model, what it will do, it will train individually and combined using a averaging process. Okay, when we are generating multiple versions of predictions and aggregate them, that is called as a bagging method. Okay, that is called as a bagging method. Boosting method means here what happens, we are going to ensemble that creates strong classifications. Okay, what happens based on a number of weak classifications, we are going to create a strong classification. How exactly this boosting method it works means, this boosting method, it will be done that build how we are going to build a model from training data means we are going to create a second model. It will attempt to create correct the errors from first model. Whatever the first model you have created, it will try to correct the errors from the first model, and then it will pass to the next. The next model, what we are going to do, we are going to add until training set is predicted perfectly. Till that, what we are going to do, we are going to attempt to correct the first errors from previous model. Okay, we are going to get a maximum number of models were added to your group. That is a boosting method. We are going to boost the algorithm or as a model. Okay, that is a boosting method. Third one is stacking. Stacking means what it will do, it will combine multiple classification or a regression technique using a meta classifier or a meta model. This is a lower level models. What it will do, it will be trained with a complete training data set, and then combined model is trained with the outcome of lower level model, like a boosting. Unlike your boosting, each level model is undergone with a parallel training. It will be parallel training. We are going to use the prediction from the lower level model is used in input for the next level model. Okay, as a training set. From that stack, which top layer of the model is there, that will be trained from the bottom layer. The top layer model has a good prediction accuracy. They built based on a lower level model. Okay, so the stack goes increasing until we get the best predictions. It will be carried out with a minimum error, and it will be combined with a meta model is based on this predictions. Okay, that is stacking method. Okay, that is a new model. And random forest means it is slightly different from other bagging method. It uses the deep trees that fitted in the bootstrap samples. The output of each tree combined to reduce the variance while growing each tree rather than generating a bootstrap samples based on observation in the data set. We also sample the data based on the features and use the only random subset. Each sample build the tree. Okay, in other words, if you take this sample of data set based done based on the features and reduce the correlation of a different output. Okay, like this your random forest, it will works. uh, for all those things I have given only introduction part. If you want to get knowledge of practical part, just I'll show the link. I'll share the link. Okay, towards data set, here we are having decision tree, how exactly it works, and code snippets also there, logical regression, ensemble samples, how exactly random forest it works, and logic regression in samples, and other models and samples, and boosting method, how exactly it will be there, how we are we are going to import and how we are going to execute. Like that, we are going to get a code snippet and we can execute it. Thank you.